Our next unit in chemistry is chemical reactions. Now, this unit is going to carry us through the rest of this semester. So, we're starting by looking at the 5 types of chemical reactions. So, our first type of reaction is a synthesis reaction. So, we can see Fred plus Wilma gives me my happily married couple. So, I add 2 separate things together in order to make one couple. Now, we use A plus B gives me AB. So this could be an element plus a compound to give me one compound, or an element plus an element to give me one compound. It really depends on the reaction. So in a synthesis reaction, we say that 2 or more substances combine to form a single compound. We are making one thing at the end. So my example here is magnesium plus oxygen gives me magnesium oxide. This is that lab we did where we took the strip of magnesium, we ignited it in our Bunsen burner, and we made that white powder, that magnesium oxide. So once we have our chemical equation, the next thing we're looking to do is balance that equation. In this example here, we can see that we have 1 magnesium plus 2 oxygens gives me 1 magnesium and 1 oxygen. We use coefficients, so we put numbers in front in order to balance my equation, make it so that I have the same number of magnesiums on both sides of my arrow and the same number of oxygens. Remember, my law of conservation of mass tells me we're going to have the same amount on both sides. Take a second and try to balance this equation. So when we add 2 moles of magnesium to 1 mole of oxygen, we end up with 2 moles of magnesium oxide. And you can see we have 2 magnesiums here, 2 magnesiums here, 2 oxygens here, and 2 oxygens here. It does not matter that this is a subscript and this is 2 oxygens in the compound. I'm just happy we have 2 of each on both sides. So our next type of reaction is my decomposition reaction. We're looking at a divorce here. I have Fred and Wilma breaking up. So now I have just Fred plus Wilma. They're separating. So in decomposition, we are breaking down. My telltale sign of a decomposition is I'm starting with 1 compound, and then I'm breaking down into, sometimes it's 2, sometimes it's 3. It really depends on what we're starting with. So in a decomposition reaction, a single compound falls apart to form more than 1 product. So we have 1 reactant and 2 or more products. So if I were to take mercury 2 oxide, that's my HGO, and it were to decompose, I would end up with mercury plus oxygen. Now remember, oxygen is one of my diatomic elements. That's my have no fear of ice cold broccoli. So my 2 oxygens here are going to stay in their pair even though we started with just 1. So take a second to balance this equation. So we can see if we have 2 mercury 2 oxides, it's going to give me 2 mercuries and 1 oxygen in my O2 form. Single replacement reaction. These get interesting. So we see my happy couple of Fred and Wilma. And then Betty Rubble comes along. And Fred decides he would be happier with Betty. So we end up with Fred and Betty here and Wilma going home alone. Okay, so this is my single replacement reaction. I am adding an element to a compound, and this element replaces another element in the compound. So a more active element replaces the less active element in a compound. And we will talk about what that means in terms of looking at an activity series in a little bit. So sometimes we will see it as A plus BC gives me B plus AC. It really depends on what we're adding together. So the beginning of this year, we put aluminum foil in copper 2 chloride. That was, we put our aluminum in that blue liquid, okay? And what ended up happening was the aluminum replaced the copper and bonded to my chlorine, making aluminum chloride. That was my clear solution. And the copper was displaced. So we ended up with a red solid. That was our example of a single replacement reaction. So take a second and balance this on your own, please. So when we look at this, we would need 2 aluminums and 2 aluminums. I have 3 coppers and 3 coppers, and here's my tricky one. I have 6 chlorines on this side, and I have 6 chlorines on this side. So I am all balanced all the way. Now here comes my double replacement. This gets real interesting. So we have Fred and Wilma, and they go and hang out with Barney and Betty, okay? And after a while, Fred and Barney get to talking, and Wilma and Betty get to talking, and they both decide they like the other one better. So Betty ends up with Fred, and Wilma ends up with Barney. It's like a perfect double date scenario gone terribly wrong to then go good again. Okay, so in my double replacement reaction, we have 2 elements switching places to make new compounds. And I'll talk way more about this in a little bit. So we have 2 ionic compounds react and exchange cations. They switch partners. And when we have double replacement reactions, they either happen or they don't. Sometimes we end up with a big ion soup. Other times we end up with a solid being formed, water being formed, or some type of gas. And we will be looking at solubility tables to figure out when a double replacement reaction happens, what forms, how do we know if it's a solid or if it's still in solution. We're going to take a look at all of that. So if I were to add calcium hydroxide to aluminum sulfate, the calcium ends up bonding with my sulfate, and the aluminum ends up bonding with my hydroxide. Now, it's super important to write out your ions, okay? Because if we have a calcium that's a +2 with a sulfate that's a -2, they're going to come together to make my calcium sulfate just like this. Now, if I'm looking at my aluminum, which is +3, bonding to my hydroxide, that's a -1, that's going to make my AlOH3. So I'm going to take a second to balance out this equation for me. So when we look at this now, I have 3 calciums and 3 calciums. I have 6 OHs on this side, and I have 6 OHs on this side. I have 2 aluminums and 2 aluminums, and I have 3 sulfates and 3 sulfates. Now, you can absolutely go each element if you'd like, but I tend to find when balancing, it's much easier to keep your polyatomics together. Keep this OH and watch it as one group. Keep this sulfate and watch it as one group. So you're not trying to balance out the oxygens between 2 different compounds. It would still work the same. On this side, I have 3 oxygens twice, so that's 6 here, and then another 12 here. So we have 18 oxygens total on this side, and 12 plus 6 more is 18 on this side. Either way, it's still going to be balanced, but it's much easier when we're trying to figure out what the coefficients are to look at this as one big group. Now, my last type of reactions we're going to talk about are my combustion reactions. These are the simplest to predict the products for, but they're arguably the most difficult to balance. So in a combustion reaction, we have the reaction of a compound with oxygen to form carbon dioxide in water. So we have this hydrocarbon. So this X and Y really can be any numbers, plus oxygen to give me CO2 and H2O. So if I had methane gas plus oxygen gas together, it would give me my carbon dioxide plus water. Sometimes it's water vapor, sometimes it's liquid water. I'm not really sure why there's a B here. Sorry. If I go to balance this equation, this is difficult because we can't keep these in groups anymore. We have the oxygen here, we have the oxygen here. We have to balance because it's only in one space. So we'll talk a lot more about balancing combustion and where you should start and end. But I hope this was helpful.